Good afternoon, everyone. I am Soumya Kumar, and today I am going to present a PowerPoint presentation on the topic pointers in C language. So, let's go. So, the first point comes about what is a pointer, the introduction part. Pointer is nothing but a pointer is a specialized variable specifically designed to store the memory address of another variable rather than its own value. It also has a memory locator. Instead of holding data directly, a pointer holds the location within the computer's memory where the actual data is value is stored. The next slide tells about the utility of pointers, basically why we use pointers. So basically we use pointer for these four main kind of things, which is for direct memory access, dynamic memory, and call by reference. And the last one is about it also very efficient in handling complex data structures. So yeah. So the next slide tells about the declaration of pointers and initialization of pointers. So to declare pointer, here is an operator called the asterisk. The asterisk operator is used to declare a pointer variable. It signifies that the variable will store an address. To initialize a pointer, it happens by assigning them the address of a variable using the address operator, which is signified by the and sign. The syntax for declaration is given by here: data type star pointer name. The next slide tells about the accessing data using pointers. So it is done by the first thing comes about what a differencing. Differencing a pointer means accessing the value stored at the memory address the pointer currently holds. And it also has an operator. The operator for differencing is the asterisk operator. When used in this context, it is called the value add address operator. There are some pointers operators in also. So let's talk about that. Mastering these two fundamental operators is crucial for working efficiently and effectively with pointers. The first operator is the address of operator. When placed before a variable name, it returns the memory address of the variable, and the second operator is difference operator. When placed before a pointer variable, it accesses the value stored of the address at contained at the pointer. The next slide has some key applications of pointers. Pointers are used across numerous domains in software development, particularly where performance and memory manages. So, the first application is dynamic memory allocations, using library functions like malloc, calloc, realloc, free to request and release memory space as needed during program execution. The next application is building data structures. Pointers define the relationships between nodes in structures like linked list, stack, queues, and trees, etc. For pointer, there is also some benefits of using pointers. Let's talk about that. The first benefit is pointer is very efficient in its kind of performance and very effective while using it. Instead of copying large data structures when passed to the functions, only the lightweight memory address is passed significantly, improving execution speed. It is also flexible in runtime, allows the creation of dynamic data structures whose size can grow or shrink at runtime, providing adaptability that fixed arrays lack. And the third benefit of it is using explicit memory control gives the programmer explicit control over the allocation usage and deallocation of memory, enabling advanced memory management techniques. While using pointer, we should also have some precautions hold up in our minds. Pointers are powerful but can introduce critical bugs if not handled with precision. Careful management is mandatory. While initialization, always initialize pointer before use. Uninitialized pointers lead to unpredictable behavior. Null checks routinely check if a pointer is null before attempting to dereference it to prevent segmentation faults. Dangling pointers after memory is freed using the pointer still holds the old addresses. Immediately set the pointer to null to prevent accessing invalid memory. Bounds checking. Be extremely cautious with pointer arithmetic, ensuring all operations remain within the legitimate bounds of the allocated memory or array. And the last two precautions are type safety. Ensure the pointer's type matches the data type it points to, and using constant is employs the constant keyword before a when a pointer should not modify the target data, enhancing code safety and reliability. So in the last, here is the conclusion and some references. So mastery of pointers is essential for effective C programming, and understanding how memory works at the fundamental level. They enable efficient code and dynamic data structure, but their power demands careful defensive uses to avoid critical errors. Some references are Key and King, C Programming, a modern approach, Dennis Ritchie, the C programming language, official documentation, consult C standard documentation for precise definitions and behavior of memory management functions. Thank you.